Our next speaker for today, we have Mr. Nandkishore Gaikwad, the Chief Architect Technology from Cognizant. Kishore is a lead enterprise solution architect based in Spain. He led the architecture and technology group for Cognizant in Swiss Re engagement. Since the beginning of year 2000, he has been developing software for enterprise business and has engaged extensively with large enterprise clients globally to design, engineer, and evolve wide variety systems, both on-premises and cloud-native infrastructure. With key focus on cloud-native solutions, cloud migrations, continuous delivery, automation, and infrastructure as code, he has been actively involved in adoption of these paradigms in enterprise IT. His session for today is SAP HANA-arriving 60x sooner, value stream thinking and infrastructure as code applied to SAP HANA on Azure.
Hello all, I'm Nandkishore Gaikwad from Cognizant Technology Solutions, working as Enterprise Solution Architect. Today, I'm going to share my experience about how we done the SAP HANA automation installation and how we arrived almost 60 times faster than the traditional way of provisioning. Yeah. What makes us to arrive the 60 times faster? Of course, the first is during analysis, we used the value stream mapping and removed the waste and then optimized the overall pipeline. Used hyper automation, specifically infrastructure as code. And during all this process, we standardized the architecture and naming conventions and the sizing. And during implementation, we integrated DevOps tool chains to achieve more automation and to standardize the overall process and reduce the manual interventions while doing so. Before we jump onto the actual implementation, how we did. So you must have seen a lot of COTS products we used, and there you might have seen that how complex and error prone those installations are. Similar such installations we are also encountered specifically with the SAP. This is a central team which takes care about the SAP based platform. Let me tell you what is that mean. Yeah. So as a central team, it is responsible for provisioning of the infrastructure environments, to be specific, on Azure, and it's do with the help of DevOps pipelines, and it mainly a VM-based deployment model for the SAP. Once that is ready, the respective other sub-departments or business units, they deploy their SAP applications on top of those centralized platforms provision environments. And then this central team is responsible for operations related to infrastructure and SAP basis. So we will cover how those environments are provisioned and how those operations are optimized with this automation. Yeah. So before we start the automation, the infrastructure was the SAP infrastructure was moved from on-premise to cloud. It is starting hurting us, and it is impacting a lot of time for provisioning of such environments. So the root cause is inconsistency in the base image. So the base operating system image, there are missing folders or missing configurations, common configurations. It happened in the various different environments. As the team members are very specific expertise in their own areas, there was a lot of handshake. For example, there is an infra team which provision the VMs, then there is a security team which configures the NSG rules and others, firewalls, networking, and there is a SAP team who takes care of the SAP installation. So to and fro, lot of handshakes, and that was the cause of the long elapsed time for any environment provisioning. Some long-running operations requires after the environment is provisioned, so those requires downtime. For examples, the system refresh or some maintenance window operations. As this requires downtime, it was planned for weekend, and due to which there was lot of such weekend requests happened, and then it impacts the regular weekdays activities. As there was the lot of environments with the different set of information or settings, so this inconsistency leads to the long operation task because every environment has the unique features, we can say, or unique configurations, and to understand and come up with the root cause analysis takes time, and that's why there are long running operation tasks. And last but not the least is the whenever we have to share regular compliance data to the regulator, lot of time spent by team manually in preparing that. So that's what's the root cause. To answer that questions, we started with value stream mapping exercise. So there was a functional silos, the different team members, they has their own semi-automation in their respective areas, were like VMs was provisioned by the VM team, then the NSC was created by some others, SAP was installed. So what we did is we discussed with all the team members, come up with all the individual activities they perform, whether that is manual or automated, list down all of them, and prepare all those value streams or value chains. After preparing that, we analyzed and identify what is not adding much value to the end result. So we removed them, we merged certain activities, and then come up with design in terms of either pipeline design or the runbook design that then we implemented to achieve this hyper automation. In terms of while doing this value stream mapping, we seen what kind of infrastructure we are building. So what is the SAP platform? So SAP platform is in the different layers like the networking and security. It can be some infrastructure activity task, and then application, SAP applications and the database. So that's the overall platform. On this platform, team performs various services and functions like the infrastructure provisioning, OS patching, then SAP installation, system refresh, kernel DB upgrade. So there are many such activities team performs as their regular day-to-day operations job. Then we identified around 8 value streams, which we feel that it's the most significant and will add to the overall transformation journey to certain extent. So the first is the golden image management. So it's the base image creations we automate using the Packer, and it also has the hardening of that image so that the security considerations also embedded within the basic image. The second is the infrastructure provisioning and SAP installation. We'll talk more about this. Third one is the OS patching. There is a monthly exercise which covers the live patching and the maintenance window patching. So it's a monthly activity, and teams spend a lot of effort in achieving that. It is specifically with the SUSE manager. Then auto start stop. So to reduce the infrastructure cost, we had to make sure that the non-production environments are stopped when it is not being used and start automatically whenever we want. Then monitor report generation. It's specifically all the dashboards were there, but it's specifically event capturing or incidents capturing and sending those reports to the required stakeholders. So that's another low priority. Yeah, DR switchover. So we've seen that the DR switchover activities, specifically in terms of SAP, it's very complicated, and a lot of manual interventions are done. So we reduce it to the single click DR's failover and failback. Then system refresh, we'll talk more about this. And the DB, HANA DB and kernel upgrade, these are regular activities whenever there is any upgrade received from SAP, we need to upgrade all the environments. So these are the 8 value streams, out of which we will discuss in more detail on 2. One is the infra provision. It's a single click pipeline, and the system refresh. It's a Azure automation runbook executed or scheduled automatically based on the scheduled window. Okay. Coming to the second value streams, which was done in the semi-automated way by the many different team members. So we converted that is a single click end-to-end pipeline. Another aspect is we also considered is how we can make it environment agnostic. So it can provision from development till production. It can provision a different type of architectures like the clustered, non-clustered, single node. It can provide multiple different configurations which are required for the different programs, so that we can manage by externalizing all the configurations in the app configuration and key vault. So that makes us our entire pipeline and code base environment is agnostic of the environments. So what it does, whenever we trigger that pipeline, it's check out the code from the app configurations, mainly the non-sensitive information, and the key vault sensitive information like secrets, passwords, so that it fetch runtime and replace that into the code during execution. Then it triggers the pipeline triggers the Terraform. So Terraform first creates the basic common resources like the resource group, virtual network, subnet, NSG, PPG groups. There is also facility that we can reuse. So what we have seen specifically in our organization is the VNet and subnets are reused. So we create one, and then in that one VNet or subnet, we provision multiple environments. So these frameworks provides that flexibility, either create a new one or reuse the existing one. After setting up that common resources, it's set up virtual machines, load balancers, then create the data disk and mount those data disks. Depending on the environment size, all those virtual machine types, the data disk sizes, their types are all configurable, and even how many data disks required for that environment, that can also configure, and that's maintained with the app configuration. So at runtime, it decide how that environment should be created or what should be the all sizes. Once that Terraform is executed, it's create and generate an output for next level, which is the operating system configuration, OS configuration, and SAP installation. For that, whatever the environments or the resources it creates, it has to pass that information automatically to the Ansible playbook. So we use Ansible playbook for execution of the operating system configurations and the SAP installation. As we are using SUSE Manager, so it's all the virtual machines which are created are registered with the SUSE Manager, so that their life cycle, patching, everything is managed by the SUSE Manager. And the DNS registration, so on-premise DNS registration, as well as the Azure DNS, Active Directory DNS registration. So that's with the help of APIs, we manage that. Then operating system configurations like the logical volume, physical volumes, then agent installations like the Commvault backup install agents, or it can be OMS agents, or depending on the need, there can be other agents as required. Then SAP HANA database. So we used SAP CLI commands for doing that SAP HANA installation, and that SAP CLI is triggered from the Ansible playbook, which takes care of installation of the SAP database on the SAP database specific VM. Then the other layers of the architecture are also installed, like the web dispatcher, the central instance, app instances, and then the number of whether that is a clustered, non-clustered, the number of instances will vary depending on what whatever is configured. And it has also flexibility to, if you have to copy from the data while generic creation of the environment, if we have to copy, because that is one of the requirement. We have seen that we can copy the data from the lower environment to higher environment, or any other reference environment that can be copied while provisioning of the environment. Then the cluster. So the cluster is mainly required to manage the SAP database cluster as well as the SCS central instance cluster. So this is it uses SAP CLI and the Unix commands to manage that cluster configure. And in the end, the infra verification and the operating systems, so whatever setup we have done, that verification, it perform, generate the report, and it fetch. So overall activity, it takes around 2 to 2.5 hours. Previously, it used to take 3 weeks elapsed time. Now it is reduced to 2 to 2.5 hours. And that's where we make it almost 60 times sooner of those environment provisioning. There are multiple variations of it. We can recreate the environment also. We can create a blank environment, empty environment. We can create the environment with some database or some data. Okay. Once the environment is provisioned, the next activity is operations. So regular operations, so like the OS patching, then upgrades. And one of the activities is system refresh. System refresh is nothing but the copying the production data to non-production environment to perform certain testing or testing or performance testing. Generally, it's done from the non-production to pre-production environment and production to the performance testing environment. Conventionally, it uses SAP-specific import-export facilities, and that is very time-consuming, and it takes around 3 days to perform overall process. So how we did it? So as this is a monthly activity, we scheduled using Azure automation, and that Azure automation also depending on the environment, what is the source, what is the target, all that information is available in the app configuration. It fetch at runtime. Then as this is the production, source is a production. So we have to ensure that it is always up and running. So there is a facility to convert the do not write to the data disk and create an in-memory snapshot. So that way we can still have the traffic incoming, but at the same time, the file system is freezed so that we can take a snapshot, a stable snapshot. So it first creates that in-memory snapshot and freeze the file system. Then we create this snapshot from the file system. Then we unfreeze and close that in-memory snapshot so that regular operations can work and directly connect it writes back to the file system. So that done, the source that is a production. So that almost approximately 5 minutes job. And conventionally, it takes around, if we use the SAP export mechanism, it takes around few hours. Now, on the target environment, we need to retain some tables, export the table data, what are the configurations are required, then setting the maintenance mode so that no unnecessarily triggers are raised, do the backup. In case of something goes wrong, then we can replace that with the backup. And this is important, which deletes the old data disk and create the new data disk from the snapshot which was created in the step number 3. As we are copying the entire data disk, it also come up with its own SAP ID and hostname. So we need to rename it. So this steps takes care of that renaming, and depending on the source environment, whether that is a clustered environment or non-clustered environment, the steps vary slightly. Then we start app, applications, and DB, and then import the configurations again. So whatever that limited tables which we need to retain on the target environment, that was exported on step number 5, imported back again. So this is overall takes around 3.5 to 4 hours. Previously, it used to take 2 to 3 days. Now it is reduced to 3.5 to 4 hours. of the execution and followed by the 2 to 3 hours of post-refresh activity. There are still certain activities which SAP team has to perform as a post activities from the SAP UI. We are analyzing that also, how we can automate it. But right now, it's some manual steps still required. So this optimize the monthly refresh from almost 2 to 3 days of weekend efforts to 3.5 of the automated hours. Okay, while doing all those things, the provisioning of the infrastructure and the standardizing and adding all the automations, one of the critical things which was required was the standardization of the architecture. So what the architecture should look like in case of simple, whether that's a non-clustered, or the complex, that's a clustered environment. Then what should be the tagging naming conventions, the resource naming conventions, what should be the DNS names, the logical names of all those VMs. So we standardize that so that all the environments are created with specific names, and it also simplifies the various operations activity. And the one most critical was the infrastructure sizing. Depending on the infrastructure sizing, SAP also needs to be tuned with the parameters so that it can perform better. So we have a defined set. We define this t-shirt sizing: small, medium, large, and extra large, clustered and non-clustered. And as these are fixed, and also we use those SAP recommended VM sizes there while defining it. And that in turn standardize what should be the SAP parameters for all those small, medium, large, and extra large. So that with those, whenever that environments are created, it standardize all those parameters. So operations activities is also reduced because we know that what is the size, and if that is some changes are required, it means we need to change the size, t-shirt size. So that way, it helps into all those operations activity, reducing the elapsed time. While doing all those activities, the DevOps tool chain we accommodated or adopted there. So conventionally, we have seen that the infrastructure as code, there is a very less adoptions of those DevOps tool chains, specifically the organizations where we were working with client. So identify what are the different DevOps tools we need and standardize the tool chain. So all those stories are being managed in Jira. Then the Confluence page is all map for that. All the documentation, Visual Studio Code is used for the code. So that it was there. Yeah. What is changed is from here. So all the code is now managed into the Git repository. We use Azure DevOps, the Git repo, then pipeline, and that pipeline, it's a Azure DevOps pipeline, Ansible for OS, Terraform for infra, Packer for the packaging of the images, then SUSE Manager for managing the VMs, SAP CLI. For set scheduled, it's Azure Automation or Logic App. Okay. Now, what we after doing all those things, what we have achieved so far. Yeah? So in terms of the provisioning of the automation, it reduces almost 3 weeks to 2 hours with single click. Standardize the architecture, infra sizing, and compliance reports are automatically created whenever the environments are provisioned. Then the infra ops automation, the OS patching almost reduced 80 hours of manual monthly efforts to the zero touch because it's completely scheduled activity. No one has to trigger it. It's automatically gets executed. Reduces the infra cost, monitoring report automatically generated. It generates the compliant report. And the SAP Ops automation, it takes around 2 to 3 days of the system refresh used to, and now it is reduced to 3.5 to 4 hours of automated refresh, followed by 2-3 hours of post activity. Automated SAP kernel upgrades and HANA DB upgrades. So these are the things we achieved so far. We are still analyzing the other how we can improve it better. All those the things, so the high level things we talked about, all those value streams are documented and published on the LinkedIn, which you can refer. So there are, the first page covers all the value streams, and then for every value streams there is a link. And we are still writing the remaining value streams based on whatever we experience so far. Okay, thank you.